Hello everyone. Now we will see the theorems based on the symmetric and skew symmetric matrix. Before that, just we'll recall this one. Already you have studied this one. What is the symmetric matrix? When the matrix will be symmetric, if A is a square matrix and A is equal to A transpose, right? If the matrix is A should be a square matrix and A is equal to A transpose, then it is called the symmetric matrix. That is, the elements are Aij is always equal to Aj. Then the matrix will be symmetric. What is meant by skew symmetric matrix? This is also only we can define for the square matrix A, and A should be equal to minus of A transpose, right? The matrix A should be equal to minus A transpose. Here the elements will be Aij is equal to minus Aji. One more thing here. What is that? The diagonal elements of a skew symmetric matrix should be equal to 0. Right? I hope you remember this one, symmetric and skew symmetric. Now there is a one theorem based on the symmetric and skew symmetric. It is given that for any square matrix A with real entries, A is a matrix with real entries, A plus A dash is symmetric and A minus A dash is a skew symmetric matrix. What do you have to prove? A plus A dash is symmetric and A minus A dash is skew symmetric. First we will consider this one. We will prove that A plus A dash is symmetric. First I will consider P is equal to A plus A dash. So that we can easily prove this one. We will consider P is equal to A plus A dash. Now we have to prove that this is symmetric. For that, what do you have to do? How to prove it is symmetric? P should be equal to P transpose, right? P, if it is equal to P transpose, then directly we can say that it is symmetric. We have considered P is equal to A plus A dash. Now I will find the P transpose. P dash, or you can write T. P dash will be equal to, now I have to write A plus A dash whole transpose, right? P is A plus A dash whole transpose. Now you know that A plus B whole dash will be equal to A dash plus B dash. By that we can write this one as A dash plus A dash whole dash, right? So this is equal to, now A dash is as it is plus A transpose whole transpose. It will be equal to A, and again matrix addition is commutative. So I can write this one as A plus A dash, right? What is A plus A dash? It will be equal to P. By this we have proved that P dash is equal to P. So A plus A dash is a symmetric. Simple one, right? Next we will consider A minus A dash is skew symmetric. We have to prove A minus A dash is skew symmetric. We will consider this as some Q is equal to A minus A dash. Now what I have to prove? To say it is skew symmetric, I have to prove that Q is equal to minus Q transpose, right? Q is equal to minus Q transpose. Now we will consider the Q dash. So Q dash will be equal to, now A minus A dash whole dash, right? So this one can be written as A dash minus A dash whole dash. So clear? So this is equal to, now A dash minus A transpose whole transpose will be equal to A. Now here I have A minus A dash, so that I can take minus common. If I take minus common, remaining with here A minus A dash. Is it clear? A minus A dash. So this is equal to, now minus of A minus A dash will be Q. By this we have proved that Q dash is equal to minus Q, right? Q dash is equal to, if you multiply negative sign, this will be minus Q is equal to Q dash. So by this we can say that A plus A dash is always symmetric and A minus A dash is always skew symmetric. Remember this important one. Now we see the next theorem. Theorem says that any square matrix can be expressed as sum of symmetric and skew symmetric matrix. Any square matrix can be expressed as sum of the symmetric and skew symmetric matrix. We will consider the proof. Okay, actually this proof is not important, but we will consider this one. Let A be a square matrix, okay? Any square matrix. So I will consider A as a square matrix. We have considered one square matrix is A. Now can I write A as half of A plus A dash plus half of A minus A dash? Can we write like this? A, right? Half of A plus A dash. So this will be half into A plus 1 by 2 into A dash plus 1 by 2 into A. So plus 1 by 2 A dash and minus 1 by 2 A dash will get cancelled, right? 1 by 2 A plus 1 by 2 A will be equal to A. Is it clear? So A can be written like this. Now here you can see this. Already we have proved that A plus A dash is symmetric, right? A plus A dash is symmetric. So if you multiply by the constant, so this will be now symmetric. Is it clear? So this is now symmetric. Understood? Now here we have proved that A minus A dash is skew symmetric. So if you multiply by the constant, that is 1 by 2, again this will be a skew symmetric, right? So this is now skew symmetric. Now by this we can say that any square matrix can be represented as sum of the symmetric and skew symmetric matrix. Proof is simple. We can write A plus A dash is symmetric. Since A plus A dash is symmetric, if you multiply by the constant, that is half of A plus A dash, this is also symmetric, right? And we know that A minus A dash is, we have proved this is now skew symmetric, right? A minus A dash will be skew symmetric. So if you multiply by the constant half of A minus A dash, so again this is also a skew symmetric. So any square matrix A can be represented as sum of the symmetric and the skew symmetric matrix. This problem is based on the previous theorem. Express the matrix. This matrix is given, it is a square matrix, as the sum of symmetric and skew symmetric matrix. You have to express this one as a sum of the symmetric and skew symmetric matrix. Actually this type of problems are not important, but sometimes we can't say, it's depend on your luck, right? Yes. Now we'll see this one. A matrix A is given. I can write, you have studied this one in the theorem, right? A as half of A plus A dash. But the problem is simple, okay? Half of A plus A dash plus half of A minus A dash. Right? So this is the sum of the symmetric and the skew symmetric matrix. You know that this is symmetric and this is skew symmetric. But here also you have to show it is symmetric. Okay? So to solve this problem, we consider this as a P plus Q. Okay? P plus Q. Here I have considered this is now P. Right? And this is Q. You have to find the value of P and you have to show that it is symmetric, and you have to find the value of Q and you have to show that it is skew symmetric. Okay? First we'll find P. What is P? P is equal to half of A plus A dash. Right? A transpose. For this we need the transpose. Here I'll write the transpose of matrix. A dash is equal to, so 2 minus 2, 2 minus 2 and minus 4. That is minus 1, 3 and 4. Next will be 1, minus 2 and minus 3. Right? This is A dash. Now we'll consider this one. Half of A plus A dash. What we have to do? Add the corresponding elements. So 2 plus 2 will be 4. Next minus 2 minus 1, it is minus 3. Then minus 4 minus 1, it is minus 3, right? Minus 1 minus 2, again it is minus 3. Next 3 plus 3 will be 6. 4 minus 2 will be 2, that is 1. Minus 4 is minus 3. Minus 2 plus 4 is 2. Then minus 3 will be minus 6. So we got A plus A dash. Now we'll multiply by the constant half. So this is now 4 by 2. So this will be now 2, right? You have to multiply each and every element by 1 by 2. So this will be now minus 3 by 2. Next element is minus 3 by 2. And next one will be here minus 3 by 2, right? So this is minus 3 by 2. Then 6 divided by 2 will be 3. 2 by 2 is 1. Here minus 3 by 2. Minus 3 by 2. And next element 2 by 2 will be 1. So this is minus 6 by 2. It is minus 3. So we got P. Now we'll find P dash and you have to show they are equal. What will be the P dash? 2 minus 3 by 2 minus 3. It is 2. Obviously it will be symmetric, right? 2 minus 3 by 2 and this is minus 3 by 2. Next is minus 3 by 2, right? 3 and 1. So next is minus 3 by 2, 1 and 3. So this is P dash. Is it equal? Yes. Both are equal here. So here we proved that P is equal to P dash implies P is symmetric. Is it clear? P is symmetric. Now similarly you have to prove that Q is skew symmetric. P is symmetric. Here I don't have place. So I'll erase this one. Then we'll prove that Q is skew symmetric. Now we'll consider Q. Q is equal to half of A minus A dash. Right? So this is equal to half into, you have to subtract those elements. It is 2 minus 2. It will be equal to 0. right? To prove the skew symmetric, always the diagonal element should be equal to 0. So 2 minus 2 will be equal to 0. Minus 2 minus of minus will be plus 1. Minus 2 plus 1 will be equal to minus 1. Next, minus 4 minus 1, it is minus 5. Then minus 1 plus 2, it is equal to 1. Then 3 minus 3 will be equal to 0. 4 plus 2 will be equal to 6. You are subtracting that. So 1 plus 4 will be equal to 5. Then minus 2 minus 4 will be equal to minus 6. Then minus 3 plus 3 will be equal to 0. Is it clear? Is it skew symmetric? Obviously, right? So this is, see, you can see this, the diagonal elements are 0. Minus 1 and plus 1. Minus 5 and plus 5. Plus 6 and minus 6. Right? So it is skew symmetric. But we'll multiply by half. So if I multiply by half, this will be 0. So this is minus 1 by 2 and this is minus 5 by 2 and this is 1 by 2, right? So this will be 0. Then 6 by 2 will be 3. 5 by 2. Next minus 6 by 2 will be minus 3. Then last element is 0. This is we got Q. Now we have to find Q dash. What is Q dash? Q dash will be now 0 minus 1 by 2 minus 5 by 2. Then 1 by 2, 0 and 3. Next will be 5 by 2 minus 3 and 0. So is it equal to minus Q? Right? If you take the minus common, it will be equal to minus Q. Is it clear? Minus Q. So this is half of A minus A dash. This is the value of Q. If I take negative common here, 0 is this. So here plus 1 by 2, here minus 1 by 2. Here plus 5 by 2, minus 5 by 2. So Q dash is equal to minus Q. So we have proved that P is symmetric and Q is skew symmetric. Next you have to express that one as A as sum of these two. You have the value of half of A plus A dash, right? That you have to write here. I don't have value here. You have to write half of A plus A dash plus and you have to write half of A minus A dash. That means you have to write this one. Half of A minus A dash. This will be now equal to 0 minus 1 by 2 and this is minus 5 by 2. Then it is 1 by 2. Then it is 0. Then the element will be 3 and here it is 5 by 2 minus 3 and this is 0. Then you have to add this, that should be equal to the matrix A. I hope you understood this one. Here you have to substitute the value of half of A plus A dash. The value of P you have to substitute plus Q. That should be equal to E. I hope you understood this one. We will see the next problem. The matrix you have to represent same, symmetric and the skew symmetric. And here I have considered the 2 by 2 matrix. Here we will solve this one. Some more problems are there in the exercise. You have to solve those problems. Okay. First we will consider this as a matrix A. So now A can be written as half of, similar to that, A plus A dash, right, plus half of A minus A dash. Is it clear? We got the matrix A and for that we need the value of A dash. A dash will be now, that is 3, 5 will be here, 3 and 5 and this is 1 and minus 1, this is 1 and minus 1. A dash, we will consider this as P and Q. So this is of the form P plus Q, right? What is P? P is equal to half of A plus A dash. So this is equal to now half of, I hope you are understanding this one. Simple it is, A plus A dash, 3 plus 3 is 6, 5 plus 1 is 6 and 1 plus 5 is 6, minus 1 will be equal to minus 2. Clear? So this is now A plus A dash. If I multiply by 1 by 2, so this is 6 by 2 will be 3 and again 6 by 2 is 3 and this is 6 by 2 is 3 and minus 2 by 2 will be equal to minus 1. Yes? So this is now, if I write the transpose of that, it will be now 3 and 3 and this is 3 and minus 1, right? So both are same. So by this we can say that P is equal to P dash. So P will be now symmetric. Is it clear? P is, now it is symmetric. Now we will write the Q. What is Q? Q is equal to half of A minus A dash. So we have to subtract. So this will be now half of A minus A dash. Subtract 3 minus 3 will be equal to 0, right? So because the diagonal element should be equal to 0. Next 5 minus 1 will be 4 and that is 1 minus 5 is minus 4 and next minus 1 and plus 1 will be equal to 0. So this is a matrix. So this one I can write divide by 2. So this will be 0 and this is 2 and this is minus 2 and this is 0. Directly we can say that it is skew symmetric, right? So this is now 0, 2 and here negative is 0. Here this is symmetric, right? So minus 1 and 3, this is a diagonal, 3 is equal to 3. So it is symmetric. So if you want, you can find the transpose of this. Transpose will be now 0 and 2, minus 2 and 0, right? So this is equal to minus q dash. So this is now clear. So the matrix P is symmetric and Q will be skew symmetric. Okay, now you have to express this one as sum of symmetric and skew symmetric. So this is I can write as A is equal to half of A plus A dash. What is that? Half of A plus A dash. This is a value, right? This I'll consider as 1 and this one I'll consider as 2. So I can write A as 1 plus 2. Is it clear? 1 is now, what is that 1? 3 and 3. This is 3 and minus 1 plus 2 is, here skew symmetric it is 0 and 2 and it is minus 2 and 0. We have to add this one. So this is equal to 3 plus 0 will be equal to 3. 3 plus 2 is 5 and 3 minus 2 is 1. Minus 1 plus 0 will be minus 1. So this should be equal to E. Is it equal to E? 3, 5, 1 and minus 1. This is still here you have tried. In the previous problem I couldn't explain these values. Okay, you have to do till here. Is it clear? See here, Hermitian matrix, a square matrix A is said to be a Hermitian matrix if Aij should be equal to Aj bar. I mean the conjugate of element for all I and j. That is Aij. If it is A1, 2, 3 element is there, that should be equal to A21 bar. That is a conjugate of that. Is it clear? One more thing you have to remember here. The diagonal elements in the Hermitian matrix is always real. Okay, remember this one. Here you can see this one. The diagonal elements are A and B is there. Here this is a matrix element A plus IB. Conjugate of this will be A minus IB. Here if I consider C minus ID, then the conjugate of here this should be equal to C plus ID. Is it clear? Then only we can say the Hermitian matrix. If you want the 3 by 3 matrix, I will consider here 1, 2 and 3. This should be real numbers. Here I will consider 4 plus I, 5 minus I and this will be now here. This is 2 and 3. So here I will consider 6 plus I. So clear? So here 4 plus I is there. Here it should be 4 minus I. Here 5 minus I is there. So it should be 5 plus I. And here 6 plus I is there. This should be equal to 6 minus I. So this is the now diagonal elements. Those should be real. And Aij is equal to Aj bar. That is a conjugate of that. Is it clear? I hope you understood this one. Hermitian matrix. Skew Hermitian matrix. Similar to this one, symmetric and skew symmetric. Here Aij should be equal to minus Aj bar. That is the diagonal elements either should be 0 or you can take the imaginary elements. That should be purely imaginary. That is, if I take Aii, diagonal elements always I is equal to j, right? Aii is equal to minus Aii bar. So this is I can write Aii plus Aii bar is equal to 0. That means the diagonal element should be 0 or it can be taken as purely imaginary. It's clear? Purely imaginary. Purely imaginary means the real part should be equal to 0. This is about the Hermitian and the skew Hermitian matrix. Here we have some of the important properties of symmetric and skew symmetric matrix. Okay. Here if A is a symmetric matrix, then A plus A transpose is also symmetric. A into A transpose and A transpose into A is also a symmetric matrix. Okay. Next one, B transpose A into B is also a symmetric. Here B is a matrix of order E. If it is A is a order 2 matrix, then B should be of order 2. Then it will be also a symmetric matrix. Next, if A is a skew matrix, then that means skew means A is equal to minus A transpose, then A to the power 2A, I mean multiple of 2 or the even power will be a symmetric matrix. N belongs to the natural number. If it is A to the power 2n plus 1, then it is called the skew symmetric. So directly we can say that if it is A is a skew symmetric, A square will be symmetric, A cube will be skew symmetric. Is it clear? A square is symmetric and A cube will be the skew symmetric matrix. Next, B transpose A into B is also a skew symmetric. Here B is same of order A. Next one, if A is the skew matrix, okay, and B is the column matrix. Column matrix means the order of the matrix should be equal to, what is the order of matrix? M into 1, right? The number of rows will be there, but column is equal to 1. Then if you multiply that, C transpose A into C is always a zero matrix. Remember this.